Namaste students. Today we will learn properties of determinants. There are total 6 properties of a determinants. So let us try to learn all these properties. Let us start with property 1. Property 1 says that the value of a determinant remains unaltered if the rows and the columns are interchanged. Take a determinant D with the row 1 as A1, B1 and C1, row 2 as A2, B2, C2 and the row 3 as A3, B3 and C3. So we'll try to interchange its column to rows. Let us take the first column and make it the first row. Second column and take the second column and make it a second row. We'll take third column and make the third row. So this new determinant thus formed is called the transpose of the original determinant D. So we can say that D is equal to D dash. Take one example and see. I have interchanged its rows to column. So and then we have simplified both the determinant and we got the result to be -5. So this proves the property 1. Property 2. If any two rows or columns of a determinant be interchanged, then the value of the determinant is changed in sign only. So let us take one determinant D with the rows A1, B1 and C1. Second row A2, B2 and C2. Third row A3, B3 and C3. We will interchange the first two rows. Let us see. We got a new determinant, that is D dash. So after we can see, yes, this is the second row and this is the first row. So this new determinant which is obtained will be equal to the negative of the original determinant, that is D dash equal to -D. Let us try to understand with this example. Yes, these two determinants I have taken, the first and the second. Yes, if I change these two rows, then I will get the sign to be negative. Similarly for the second. Let us go to the third property, which states that if a determinant has any two rows or columns identical or same, then its value is equal to 0. Let us take one determinant D whose two rows are identical, A1, B1, C1. The first row and second row A1, B1, C1. These two rows are identical. We can see here these two first and the second rows are identical. So if these two rows are identical, then we can say that the value of the determinant is 0. Let us try to understand with this example. I have taken these two determinant whose in the first we have taken two columns identical and two rows identical, and we got the resultant to be 0. Let us move to the fourth property, which states that if all elements of any row or column be multiplied by a number, then the determinant is multiplied by the same number. So let us take a determinant D with rows A1, B1, C1, A2, B2, C2 and A3, B3, C3. Let us suppose a scalar quantity K multiplied with this determinant, then this K will be multiplied with all the elements of the first row, which is as shown there. So we can understand this concept more better by stating one example which I'll show. In this example we can see that each row has a scalar quantity K, and we can take it common, and if we take the k's common, we'll get k to the power 3 outside. Let us go to the fifth property, which states that when each elements of any one row or column can be expressed as a sum of two elements, then it can also be expressed as a sum of two determinants. Let us see with an example. Let us take a determinant D in this way. whose first row is expressed as a sum of two elements. So this particular determinant can be expressed as a sum of two determinants whose first determinant can be written in this way and the second can be written as x, y, z, a2, b2, c2 and a3, b3, c3. So this is a sum of 2. So let us take one example here. This is the matrix which I have shown here. I have splitted the same matrix into two and I have shown here differently whether their result is same or not. We can see here, you can pause and see this. Yes, they are equal. Let us learn the sixth property now, which states that the value of a determinant is not altered by adding the elements of any row or column the same multiple of the corresponding elements of any other row or column. Let us try to understand this property by taking a determinant D. So we'll try to keep the second row stagnant and use try to change the row 1 and row 3. So row 1 to R1 plus MR2 and row 3 by R3 plus NR2. So here we will write D dash as the new determinant formed with this application. So we'll get this new row. We'll keep the second row same and we'll get a new third row which is as shown here. So the result of this determinant will be same as the original determinant. Let us try to understand with this example. I have taken the original determinant here and again I have tried to use this property with the another determinant D dash. So in both the cases we have tried to solve and see that both the resultant is same. Hence this is how we can prove the sixth property.